Hey everybody, it's Miss Sorrells, the nicest teacher of all the math teachers here. I so kindly provided you with notes, unlike Mr. Nelson or Mr. Paper ever have. So you're welcome for that.
You're an enabler.
If you do not have this paper, unfortunately, you are going to have to copy it all down or come to tutorials in the morning and get it down. So we're going to start with what is a proportion. So we're looking at proportions and scale factors today. What is a proportion? Well, a proportion is just two equivalent ratios. So I have good news for you. You've already been doing proportions and you haven't even known it. When you set up a ratio and you find something that is equal to it, you have then found a proportion. Okay, so we're going to look at a few 5 problems. Look at number 1. This one, we are going to find the proportional relationship, meaning we want to make it a proportion, meaning it needs to be 2 equal ratios. So it's just like you've been doing. You need to find the rule and then apply it. So the variable we're solving for is x, okay? And to get from 10 to 50, when I am scaling, it has to be multiply or divide. We are multiplying by 5. So you'll do the same thing at the top, which would leave us with x equaling 15. It's as easy as that. That's what a proportion is. So over here, x is equal to 15. Okay? On the second one, same scenario, just a little bit different setup. This time the fraction on the left has the variable or the letter or the unknown. Okay? If this confuses you, I'll show you a different way in just a second. But what I do know is I'm solving for the one on the top. So I need to use the bottom 2 numbers in order to figure that out. Second of all, I don't know what x is, so I can't go left to right like I've been doing. Like I know 8 times 2 is 16, but I don't know what to multiply by 2 because x is what I'm solving for. So you'd have to go backwards. So 16 divided by 2 is 8. And so we would go divide by 2 is equal to 8. And so up here I do the same. I would do 4 divided by 2, which would leave x with a value of 2. The other thing you can do, because they're equivalent, you can set them up like this. So don't switch the numbers. The 4 still needs to be over the 16 and the x still needs to be over the 8. Just switch which one comes first. So this one you can clearly see I'm still going to have to use the bottom numbers because those 2 are there. And then I'm doing 16 divided by 2 and 4 divided by 2. So same thing, same answer you've got, except you've just flip-flopped the order of the problem. Alright, so this is definitely a real-life situation where you would need to use what's called a scale factor. Oh, backtrack, I do need to talk about this. When you are multiplying across, these are what's called scale factor. You are scaling it up. So if this was like ingredients for a recipe and I needed to make 5 times the recipe, I wouldn't add just 5 things. I need to multiply it by 5. So a scale factor, you might put this to the side, and if I'm writing it, I'd say you should probably write it, is when you multiply, okay, to create an equivalency. Okay, so number 3. Real life situation here. We've got a picture and we're going to solve for the distance from school R to school T. Now you got to look real close. School R is over here. School T is right here. Okay, couple things. Got to pay attention to this down here. It says on the map that from school R to school T is 3 inches. Now if you think about this in real life, think about a ruler. A ruler is 12 inches. Do you think really the distance between these two are in actual life is 3 inches? No. And that's where the key right here, or the scaling factor, is going to come into place. Okay? So they've told me on the map it's 3 inches between the two. Alright, I've written you some steps. So we got to pay attention to the scale given, which I just starred and underlined. And this is our ratio we've been given. So when we have a ratio, we're going to write it as 1 inch over 2 miles. That's my ratio. Okay? So actually we could do 1 and then we're going to label out here. So those are the same thing. Okay, we set up the ratio and we labeled our numbers. This is inches, this is miles, and then we're going to solve for the distance. And over here you are creating an equivalent ratio, which is a proportion, But we've been given one more piece of information that needs to place in here, and what that is the distance from R to T on the map. And it's 3 inches, so you have to say, am I going to put it on the top line or the bottom? Well, it's going to go on the top because the top is the line describing inches. So this is now X. I'm trying to find out how many real miles it is between distance school R and school T. So just like you've been doing, how do you get from 1 to 3? Our scale factor is 3, and so you're going to use the same scale factor down here, and 2 times 3 is 6. So an actual distance is 6 miles between school R and school T. And I've been talking a lot in my classroom about making sure you're understanding what the question is asking. Don't just put 6. 6 what? 6 miles, 6 cars, $6. If it doesn't have the meaning behind it and you don't understand what you're solving for, it's really hard to check that your work makes sense. Okay, so make sure you've been practicing labeling what you were doing. Okay, number 4 is very similar, except you are not given a map. But you can draw a picture to help you visualize it if you're like me. I need to see a picture. Okay, so it tells us the scale on the map is 1 centimeters for every 4 real miles. So every centimeter on the map is real 4 miles in real life. Northridge Middle and Northeast Mall are 3 centimeters apart from each other on the map. Okay, what is the actual distance? So miles, this is what I'm solving for. The actual distance is going to be in miles from Northridge to Northeast Mall. Okay, we've been given our ratio. We've been told that 1 centimeter is 4 miles, but first let's draw a picture. Let's say Northridge, let's do NRMS, is right here. Okay, and let's say the Northeast Mall is over here. So you just have your 2 places, and it tells me on the map how far they are apart. They are 3 centimeters apart. So from here to here is 3 centimeters, and I've been told that 1 centimeter is equal to 4 miles. Okay, so let's do what we did last time. Let's set up our ratio given. We know 1 centimeter is 4 miles, and we know that on the map the distance from Northridge to Northeast Mall is 3 centimeters. We're going to put that on the line, or the numerators, because centimeter is on the top. So 3 centimeters, and we want to find out how many actual miles it is. So how do I get from 1 to 3? Your scale factor, you're going to have to multiply by 3, and you do the same on the bottom. So in real life, the distance between here and or Northridge and Northeast Mall is 12 miles. So once again, 12 miles from Northridge Middle School to Northeast Mall. Put some meaning behind your answer. Don't just slop a number down and hope that it's right. Alright, pause it if you need to catch up. Again, if I wrote it down, you should too. Alright, we're going to end on an easy one, and in fact, this is one y'all are probably used to seeing at this point. You're probably feeling like you're hearing a broken record say over and over and over again what to do. Okay, so for every 2 text messages that Anna sends, Kim sends 5. How many text messages would Anna send if Kim sends 40 messages? Okay, your question is asking you how many text messages would Anna send. So do we know how much Anna would send? No, because it's asking us how many. That is our goal. Maybe you even practice rewriting your question. How many messages Anna sends? That's what I'm solving for. That's my goal in this problem. So let's set up the problem with the ratio. We've been told that if Anna sends 2, Kim's going to send 5. So 2 is Anna and 5 is Kim. Okay, and please make sure you're labeling. Like I've told my students lately, this saves you from having to go back and read in the word problem, because we all know that once you read it once, you're not likely, from what we've seen in class, to go back and read it again, or you don't want to. So if you label, you're saving yourself from having to go back and read again. Okay, and then we're going to equal it to, we've been told that Kim is going to send 40. So we've been given a little bit more information, and we want to know how many messages Anna sends. That's our variable right here. That's what we're solving for. All right. Scale factor, 5 times 8, and so up here is times 8, so x would equal 16, meaning Anna would send 16 text messages if Kim sent 40. And that's it. Okay? Again, make sure you're practicing setting up the problems. It's really going to help. And what this is telling you, the scale factor is telling you maybe that this went on for 8 days or whatever it might be, but you're having to multiply it by 8, which means your scale factor. Your rule on these on equivalent ratios is not going to be adding. It's always going to be multiplication. Alright, again, make sure you have all of this awesomeness down. Okay, make sure you fill out the Google Doc and do the best you can. We'll be looking at how well the whole 6th grade answers as a whole. And then also make sure you bring your notes to class, because before you can ask a question in class, you've got to have your notes out and look at these examples to help you. If you have any questions, come to tutorials. We'll be glad to help you.